Welcome to my channel. So many people have been asking me, is it only chemistry that you teach? We will only see chemistry in your channel. What about other science subjects? Well, it's just because I never had time to go into other subjects like physics, further mathematics, and mathematics. And today I want to demystify one important concept in physics, and that is internal resistance of a cell. Internal resistance of a cell. When we talk about internal resistance, it's a resistance that comes as a result of the opposition offered to the flow of current by maybe due to the nature of the chemical that was used to manufacture the cell. So every cell has an internal opposition, which is called the internal resistance. Now, how do we distinguish internal resistance from other resistors, or internal resistor from other resistors? Now, we simply use small letter r to represent internal resistance. So whenever you see a small letter r, it means internal resistance. And when you see capital letter R, it means external resistance. Okay? Now, this is a circuit diagram that enables me to summarize all you need to know as far as internal resistance is concerned, and how to go about calculations involving internal resistance of a cell. Now, a circuit might contain only one cell. If a circuit contains only one cell, it means there is only one internal resistance and one EMF in that circuit. Then, if a circuit contains an external load, what I mean by external load is external resistance, which is represented with capital letter R. If it contains only one, of course, you will see only one R, only one resistor in the external circuit. So all you need to do, that is a simple circuit. Why is it a simple circuit? Because it just contains only one EMF, only one internal resistance, and one external load. So that kind of circuit, you can simply resolve it using this formula that I wrote here on the board. You can see I, which is current, equals E over R plus R. So I here means current. E here means EMF of the cell. R here means external resistance, as you can see in the circuit. Small r here means the internal resistance, which is the function of the opposition offered by this cell. Alright, so now when I want to find current in that kind of circuit, or in this type of circuit, I simply need to apply this equation. I equals what? E divided by R plus R. Now, when you now have more than one cell in your circuit, or you have more than one resistor in the external circuit, how do you find current flowing in such circuit? First of all, you need to know that cells can be added either in parallel or in series. Is that clear? Cells can be added in parallel and in series. So anytime you have more than one cell in your circuit, what it means is that you are either going to add the EMFs of the cell in parallel or in series. So it depends on the type of connection. So it is not left for you to know what we mean by series connection and parallel connection. So when you look at your circuit, you should be able to know when the components like the cell or the resistors are connected in parallel or in series. Okay, now in this case, now look at the circuit diagram. In this case now, you have E1. I hope you can see carefully from there. Okay, you have E1, you have E2, you have E3. So these cells are connected in series. Okay, this is series connection. So for us to find what we call the total EMF, so we simply get the algebraic sum of electromotive force of cell 1 added to that of cell 2 added to that of cell 3. Okay? So you add up the EMFs of the 3 cells together. So this is how to add in series. So when your cells are in series, you add them this way. But when your cells are in parallel, when the cells are in parallel, for example, you have something like this. You have something like this. Just give me an example. So look at this carefully. Can you see that? So now this type of connection here is called parallel connection. So if you have E3, E2, E1, and I'm asked to find the total EMF of this, assuming cell 1 has EMF of 2 volts, and this one has EMF of 2 volts, and E3 has EMF of 2 volts. The total EMF of parallel connection is just the EMF of one cell. EMF of one cell. So you take one, since all of them they are equal in magnitude. So you have 2 volts, 2 volts, 2 volts. So you take the EMF of one of the cells, which is 2 volts. Now when you have cells in series, you sum up all the EMFs of the cell. For example, if I have 2 volts for E1, 2 volts for E2, and 2 volts for E3. So the total EMF here will be the EMF of what? The 3 added together. Is it clear? Okay, now remember that every cell has a component internal resistance. So as I'm adding the total EMF of these cells, I should also be adding the internal resistance in series. The internal resistance should be added in series as well, which is R1 plus R2 plus R3. So total internal resistance is the sum of the internal resistances of each of the cells present in the circuit. But in this case, when you have parallel connection, the total internal resistance of this parallel combination will be just the way we add resistors in parallel. So when you want to add resistance in parallel, it is always a reciprocal of what you have there. So you have 1 over total internal resistance being equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so if you have at least each of the internal resistors to be, say, 1.5 ohms each. So what I'm going to be doing is 1 over total internal resistance is equal to 1 over 1.5 plus 1 over 1.5 plus 1 over 1.5. So that will give me the total internal resistance of the cells in the circuit. So when I'm done with this, I need to find out these sums. When I'm done with this, I will now come back to this formula to find the current that is flowing in the circuit. Remember that the formula is current equals E total. It's not E total because here I've added all the EMFs in the circuit. So E total, total EMF divided by total external load, external resistance, plus total internal resistance. So this is what you will use to find the current flowing in this type of circuit where you have multiple components. In the circuit. So when you have a simple circuit like this, you simply need to use what this equation I is equal to E over R plus I, because this one contains only a single component. Okay, so that is taken care of. Now the next thing we need to discuss is what we call lost volt. and terminal PD. Lost volt of a cell and terminal PD. Now, it will interest you to know that when you go to buy battery, when you go out there to buy battery, Tiger battery, or any kind of Leclanche cell, there's always something that's written on the body of the battery. You will see where they wrote 1.5V. That 1.5V is not the voltage of the cell. No, you're making a very big mistake. Don't call it voltage. That 1.5V is simply the EMF of the cell. Is the EMF of the cell. Okay? Now, but when you now bring the cell now to your lab and then get a voltmeter to measure the potential difference, it will surprise you that your voltmeter will not give you that exact value, which is 1.5. It will give you a value that's less than 1.5. Now, what happened? That means there is a loss in what? In voltage, which is what we call lost volt. It's supposed to give you 1.5 as it is written on the body of the battery, but it's not giving you 1.5. So what you have is maybe 1.4 or 1.45. So there is a voltage loss. So that diminished voltage is what we call the terminal PD, while the voltage that is lost is called the lost volt. So now, what is the relationship between these concepts or these parameters I've mentioned? Lost volt, terminal PD, and then EMF of the cell. So let us go to the board and demystify the process. Okay, still on this our almighty formula. I is equal to E over R plus R. Okay, let me clean here so that it will be a bit clearer. Okay, so we have current is equal to EMF of the cell divided by R plus small r. Okay, now if I am to cross multiply, I have that E is equal to I bracket what? R plus small r. And then if I should open the bracket, I have IR plus IR. Now I want you to observe this closely. E is equal to IR plus IR. Now this, we all know that from Ohm's law, the product of current and resistance is voltage. Whenever you see the current being multiplied with the resistance, the result is what? The voltage. So that means that IR here represents V, and this other IR represents V. So to distinguish between this other one and this, I have to use capital letter V and small letter v. So this capital letter V is what we call terminal PD. This one is called terminal PD of the cell, while this one is called the lost volt of the cell. So what it means is that whenever you're asked to find the lost volt in your circuit, you can either calculate it by multiplying the current in the circuit by the internal resistance in the circuit. Remember, for a single component circuit where you have only one cell, you can only use one internal resistance. But once you have more than one cell, this R will now be the R total. That is, you have to get a total depending on the type of connection that you have, whether it is series connection or parallel connection. So the same thing is applicable to this one. When you have single component circuit where you have only one external load, you can use IR to find the terminal PD. But when you have more than one resistor in the circuit, that means you need to find the total or effective resistance in the circuit by adding either in parallel or in series, depending on the type of connection that you have. Okay, so sometimes You can obtain this one by subtracting the EMF of the cell from this one, just as it is stated in this equation. So if I have that EMF of the cell is equal to terminal PD plus loss volt. So if I'm looking for loss volt, it will be EMF of the cell minus what? Terminal PD. All right. So that is how to go about loss volt, terminal PD, and EMF of a cell. So once you apply all these things in any calculation that has to do with internal resistance, I assure you, you will get your answer without any problem. All right, so this is where I'm going to stop for today. In our next lesson, I'm going to be taking you through how to handle other calculations involving electricity, like buying and selling of electrical energy. I'll also take you through potentiometer, calculations involving, the ammeter, how to change an ammeter to a galvanometer, all those calculations. So we'll take time to demystify all that. Please don't forget to subscribe to this channel. We have more to give to you. All you need to do is to keep in touch. Please press the bell notification for more updates. Thank you and God bless you.